Okay, today's May 26th, 2011. We're on text page 396. Blue Notebook, page 487. That's a lot of pages in that book. And lesson 8.1. We're going to go over sine law today, which is not the same as our basic trig ratios. Remember, all the ratios we did last chapter deal with right angle triangles. We're about to learn two laws in this chapter that will teach us how to solve for sides and angles of non-right angle triangles. In fact, they have to be acute triangles, which means there's no obtuse angles. Okay? So if you take a look at this, even though it's not perfectly drawn, these are all acute angles here. It's not a right angle triangle. I'm just going to tell you that's not 90 degrees there, okay? We're just going to pretend it's not. So we're going to be using something called the sine law. Now, in order to apply sine law, remember this is a little thing I put on your text, you have to know how to name a triangle. So, first off, I'm going to call this angle A, which means the opposite side of this triangle is side A. Whatever the name of the angle is, so angle A, the opposite side is the lowercase of that letter. So for instance, I'm going to call this angle B. Opposite side is side B. And finally, angle C. Opposite side is side C. So without all of those arrows drawn in there, when you go to name a triangle, it should be done like this. It should look like. So we'll call this A, angle B, side B, and angle C, side C. This is imperative that you know how to do this. If you do not name the sides correctly, you will not be able to plug numbers into this law properly. Okay? Okay, I'm glad that's simple, because our formula reads, there are two types, doesn't matter which we use, but side A divided by sine of angle A is equal to side B divided by sine of angle B, which is also equal to side C divided by sine of angle C. So if you notice, the side and the angle are matched up together. These are ratios. We set up ratios. Now, what's important is, technically, the reverse of this works out fine too, as long as you reverse everything. So I'm going to draw it again. Sine A divided by side A is equal to sine B, so angle B divided by side B, which is again equal to sine of angle C divided by side C. So these are both the exact same thing. It doesn't matter which one you put on top, as long as you put the numbers in correctly and you equate it as a ratio. Okay, sorry. Make sure you know that this is called sine law, the squiggly line. So these are our sine laws. You need to memorize this formula in order to solve for these, okay? Now in the book they've given us some examples. So let's go through the very first example, number 1. So in this example, they tell us that this angle here is 66 degrees. They tell us that this angle here is 52 degrees. And they've told us that this side here, 2.5 kilometers long. Okay? The question asks us to find this distance. They call it P. Okay? They use a word problem for it, but this is essentially the diagram they've drawn. We need to solve for this side P. Now, it doesn't matter what letters they use for a triangle. Okay? What I'm going to do is I'm going to quickly draw the exact same triangle again. So even though they've called that side P, I'm just going to rename it. It doesn't matter what letters I put in. Those are all just variables. So I'm going to rename it because my sine law has been given to me with ABC. I'm just going to rename this triangle. This is my angle A. This will be my side A, angle B, side B, and finally angle C, side C. So I've renamed the triangle, and I put those values in once again. Angle B looks like it's 66 degrees. Angle A is 52 degrees. And side C is 2.5 kilometers. Okay? Now, what I'm going to do, now that I have my new triangle, I'm going to write my formula. Actually, we'll do it in the colors just for you guys. Oh, I can use these colors. Side A is equal to B is equal to C. Okay? Now we look at these. I'm going to plug in the numbers they've given me for the variables. What's important is I need to find a ratio. I need to complete a ratio in this question. So first off, my side C is 2.5 kilometers. So I'm going to replace this letter here with 2.5 kilometers. So I'm going to start doing this in black now, okay? So that is 2. C will be 2.5 kilometers divided by sine C. A side B I don't have a measurement for, so I leave it. My angle B is 66 degrees, so sine of 66. And same idea with my A. I don't have the measurement for side A, but angle A is 52 degrees. Now, unfortunately, I don't have a single complete ratio. And in order to use my sine law, I need a complete ratio. So you guys notice there's a variable, whether it's on the top or the bottom of all of these fractions here. According to what I have, I can't find sine law. But let's go look at this triangle again. Is there any other information I can figure out from looking at it? What? Angle C. What is angle C? How can I find it? Sorry. Yeah, we know a triangle adds up to 180 degrees. So if I subtract our other two, and 52, okay, what does it give us? 62 degrees. So angle C is 62 degrees. Great. What that means now, I can head back down here. I can replace this C with my 62 degrees. Now I have a complete ratio. C is a complete ratio. Excellent. Okay? So I have a complete ratio, which means I can now solve for either B or A. I can solve for both. It doesn't really matter. I can set them both equal to that ratio. Let's look in the question. They're asking us for P, and we renamed it side A. So in other words, they want us to solve for that. Okay? This is a great example. So what's going to happen now is, because I'm not solving for side B, these are all equal signs, okay? If you guys notice, these are equal signs. That means these are all equal. So first ratio is equal to the second, and it's also equal to the third. Since I don't need to solve for side B, I can just cross it out. I don't need to include it in my formula. So I now have side A, which we're trying to solve for, divided by sine 52 is equal to 2.5 divided by sine 62. Okay? Now this becomes an algebra question. Simple as I need to isolate side A. So we know about our cross multiplying stuff, but I'm going to tell you the fastest way is I only need to move sine 52. This sine 52 needs to come over to the other side, so it needs to go to the top of the fraction. The idea is I have to multiply by sine 52 both sides. Okay? So when I do that, our next line is going to read A is equal to 2.5 multiplied by sine 52 over sine 62. Now, some of you are going to ask me, sir, could I have solved for sine 52 first? and had a decimal value, yeah, not a problem at all. So let's do that right now. Sine 52 was equal to 0.788, okay? And it goes deeper than that. So I'm going to write on top of it. I could have replaced this with 0.788, right? And the same idea with sine 62. Could I solve for that? Sure, I could have solved for that too. Sine 62 is equal to 0.8829, blah, 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 keeps going, okay? So in my next step, I'm actually just going to write those in so we know. But if you were so inclined that you want to solve for the sine 62 and 52 before you moved anything, that's fine. You could have done that. So I get A will equal 2.5 multiplied by 0.788 divided by 0.8829. All right? I just have to carry this out. So 2.5 multiplied by that. What I'm going to do is I'm actually going to put that in the calculator just to show you as one equation. Okay? 2.5 multiplied by, remember that used to say sine 52. Sine 52 is more accurate than what I have, 0.788. I've rounded, if you guys notice from there. Okay? So what I'm going to do is I'm actually going to put in sine 52, end bracket, and I have to end it twice because there's another bracket here. So the calculator knows to do sine 52 first, then to multiply by 2.5. That equals 1.97, that's a 9, divided by 0.8829. And once again, if you guys remember from before, that used to say sine 62, my 0.882. So what I'm going to do is I'm going to take that value, divide it by bracket sine 62, and again, I got to end the bracket twice here because of the way my calculator works, is equal to A equals 2.23 kilometers. And we scroll way back up to the top. Our P is 2.23 kilometers long. That's what they were looking for. That is our final answer to that question. Jeffrey asked if, because of the order, if he did it in a different order, if he divided 2.5 by sine 62 first and then multiplied by our sine 52, that would have got you the exact same answer. Okay? As long as you follow the rules of algebra, it's fine. Remember, the whole idea is we just had to isolate A. So that's right. You could have divided that first, then brought over sine 52 and multiplied. It would have worked out fine. Okay, so please do, right now, from your text, page 402, numbers 1 and 2, they deal with solving sides of a triangle using sine law. I want you guys to do that right now, and then we'll do an example to solve an